This is your machine, a 16-inch pacer. It's equipped with 4 overhead, 2 lower unwind rewind combo units, and 2 directional main rewinds that go forward, off, and reverse. All of them are equipped with inflatable mandrels. These are the controls for all the upper unwind rewinds: gauge, regulator, switch for mandrel. These are the lower controls. Same thing: gauge, regulator, switch, mandrel. These switches allow you to choose between unwind and rewind mode. You have main mandrel pressure. This pressure dictates the pressure for all the mandrels. One kind of rules them all. Your main unwind, which is right here at the beginning of the machine, is controlled by a automatic tension unit, which uses an ultrasonic sensor. Being ultrasonic, you will never want to have a fan blowing directly near the vicinity of the sensor, because it'll blow the sound waves and cause errors. There's the mag power controller that controls that whole system. This is the HMI that controls island placement, counter. This is your AccuWeb web guide controller. This is the web guide itself. The web guide consists of an entrance idler, an exit idler, the web guide itself that pivots, and a built-in splice table that has pneumatic locking arms. You lock them down when you're ready to make a splice. Make your splice, tape it up, and release your pressure. Your web path going through the web guide would be just as shown. Coming into the machine here, we have a basic idler that's on a shaft that's supported between the side frames. There's a screw on each side. These are assist idlers that work with the score unit. The score knife blades are mounted on the shaft, and they cut onto the hardened roll here. This is the first die module or station. It is controlled by the servo. The machine only has one servo. The rest is controlled by a separate motor. This one has different functionality that will adjust speed. It'll create a ratio between this module and the rest of the machine. You can make this go slower or faster for different processes. In this module, you'll see we have inner side frames, which are, just for an example, you guys didn't purchase these, but if you ever need them, we do have them. It allows you to use a smaller die inside there. This is a 10-inch die that we're using just to run this test. This is a hold down. This is not the optimal way to hold down on a die, because we were just holding down on the bearing blocks at the moment. You would normally want to use a full truck assembly to push the pressure down on the bears rather than the bearings. We did this just because of a test and this little demo, and so you guys can see the hold downs. If you come over here, this is an anvil bearing block, which is called a standard die block, and it is also used for dies. It has a 1-inch journal. There's also another type of die block that we call a twist block that is really handy for when you're installing dies. You would use a standard die block like this one on the opposite side, on the inboard, and you'd slide your die in, and then you'd come and you put a twist block on this side for a very easy installation. This bearing block down here is your support shaft bearing block, which is a bigger bearing. It also has its cover. It's greasable through that port. This is razor slitter assembly. The razor slitter supports these razor blades that are installed in this little T-channel here, and you tighten them down with this little nut. You measure, get them in a place where you want them. It has a fine-tune adjustment. This knob makes the whole unit go back and forth. You have 2.5 inches of travel. Moving to the next station here, we have the truck assembly. This is your truck bridge. This gets bolted down on top of the side frames. There's tapped holes there. These are hydro jacks used with these nice little cam locks here for easy installation, quick. Below it, this bar is your pressure bar. Pressure bar has bearing blocks which put the pressure directly down on the bearers of the die. There is no die in this position at the moment. I have it in here just as a demonstration so you can see how it is installed and how it looks. If you were to use this with a die, you would want to take this bearing, well, there's a little set screw and these little, it's a lock block. There's a little set screw there on each side. You loosen those up, they slide on this bar, and you'd want to line up your bearings on these parts of the die. That's called the bear, and that's, you would push your pressure down on that. The hydro jacks have gauges so you can record what your pressures are that you've used, and you can keep track of numbers. They're really nice, and they provide a lot more pressure than a normal standard hold down. Standard hold down will give you, with the human hand, approximately 200 pounds of pressure. These obviously go up to 3,000. Moving along, we have stripper bars. These stripper bars allow you to do the island placement and gap separation. As you can see, this material is cut across on this side. This liner is being taken down in between these bars, and another liner is being reintroduced above this bar. So this liner here and this liner here are two different liners. In between, this gap is being created. This is a nip roller that is special to use with this bracket and this setup. This is not your specific roller. Your roller is the full width of your machine, just like this nip is right here. You see the bar on the left. It has a large angle cut that provides a really sharp turn to allow the part up above to slide and peel off to move over that gap onto the other liner. The bar on the right is square or rectangle, and it has rounded edges on it. This is a manual register. You would web around these two idlers in an S-wrap type configuration from anvil to die or die to die, and adjusting this will allow you to move your die cut on your web. It's like a fine-tune adjustment. The pneumatic nip is controlled by air. It has adjustable pressure. It's controlled by a gauge, regulator, and switch. And you have up is up, down is down. You adjust your pressure, how much pressure you need to put down. This nip unit can be installed in any of the top stations in the machine. You can move it. There's just two bolts here, two bolts on the other side, and you have the air connection that is auto off when you take these fittings out. You move it, you can, if you need to completely remove it from the machine, you pop these out, it's not a big deal. This is the surface winder. The surface winder is used to apply pressure while winding. It is controlled pneumatically through a gauge, regulator, switch, and you have a switch for the inflate the mandrel there. Done. To power up your machine, you'll need 230 volts AC, 3-phase, 70 amp service. Air pressure, 100 psi, 2 to 3 CFMs. To turn on the machine, you'll first want to start by turning on your main disconnect and have air pressure applied, the air pressure input. The machine is equipped with 3 e-stops, one on the front control panel, one on the left control panel located by the HMI, and one on the right side located by the rewinds. There are also 2 door interlocks on the rear of the machine. Locks are located on the 2 rear doors of the machine. There are 2 pieces. These doors have to be closed to run the machine. You're going to want to make sure that that rear disconnect is on, your air pressure is applied, all your e-stops are in a proper position, and your rear doors are closed. The next step would be turn your main power switch on. If all your e-stops and your doors are in the proper positions, the e-stop reset light will be illuminated. If it's not illuminated, one of the buttons may be pushed in or the doors may be open. The next step would be to push this button. The button will turn off. At this time, the drives, AC drives and servo drives are all booting up. When they're ready, the system ready indicator will be lit, and then you could enable the drives. And you'll have notification that your drives are enabled. Your red stop light should be on at this point also. The red stop light turns off when something is blocking the light curtains. If there's an intrusion, the machine will not run while there's an intrusion in the light curtain. If you hit the e-stop, you notice that that blue light will become illuminated. To reset it, bring that out and hit that again. Basic machine functions. Start, stop, your speed pot, 0 to 300 feet per minute. Jog, which is a slow run. You can jog while you're inside of the light curtain. Slow, it's a slow speed. You cannot run while you're inside the light curtain. Counter reset, which will reset your counter when your preset is reached. Advanced retard. The advanced retard controls this last station. It goes really slow. It advances the anvil forward or backwards if you want to advance or retard a die cut. And you have a low roll bypass switch. Low roll bypass bypasses the low roll alarm. The low roll alarm works with the mag power system. You will set a specified roll diameter that you would like the machine to shut off at on your main unwind. So example, you start with a 30-inch roll and you have a 3-inch core and you want the machine to shut off at 3.25, a little bit above your core basically. The machine will stop. It's a pretty nice feature. So after the machine has stopped, because it sensed 3.25 or lower, you will have to turn this low roll bypass switch on to continue running the machine to finish off your roll. Pause. This is the MagPower automatic web tension system. This will automatically adjust your web tension on your main unwind through adjusting the brake pressure. The MagPower has 2 modes, manual and automatic. This button changes from mode to mode. In manual, you'll have an M all the time. In automatic, you'll have 3 different letters here. You'll have an H when you're in stop mode. You'll have an A when you're running. And you'll have a S during stop. So if you're running and you press stop, this will briefly change to an S and then we'll change to H. What's happening during that S time is there's a stop timer in there that you can adjust and it'll apply more brake pressure during the stop mode. If you're using heavy materials and have a wide web, it'll help you stop the machine or keep it from free rolling through inertia from the weight of the roll. If you're going to use auto mode, you're going to need to input some parameters. To input parameters, you press program. The first group is going to be roll dimensions. You're going to want to input the largest size of your roll, your full roll diameter. By default, I just have 40 in here. You could change this. This could be changed on a job per job basis, and should be to properly use it. By default, it's 40. I have a 4-inch core currently in there. This you shouldn't have to change unless the mandrel gets moved or the sensor gets moved. But this is basically from the sensor to the center of the mandrel shaft. Like I said, this shouldn't change unless the sensor gets moved horizontally up or down, or the mandrel position gets changed. These parameters, these are all default parameters you shouldn't have to mess with. Besides this core offset applies a slight amount of air pressure at the core. So if you set up a 40-inch full roll and a 4-inch core, it would have 0 psi when you hit the core. If you wanted to have a little bit of tension, you're going to want to bump this up. Your stops and alarms are where you're going to want to set where you want your machine to stop with the low roll. And that would be your minimum diameter. Right now I have it set so at 3.9. When the roll goes below 3.9, it's going to turn the machine off. The max, we don't use maximum diameter on this system. The first parameter in the group is the stop time. This is the stop time that I was telling you about when it switches modes from auto to hold. It applies pressure, extra pressure for 1 second to help the machine stop. 1 second is default. I don't change that unless there's a really heavy wide web, big rolls. You could choose to lock this if you don't want operators to change parameters. Sensor line is stuff that you shouldn't really have to adjust. And then we're back to roll dimensions. So to run the system, you mainly need to put in your full roll diameter, your core size, and if you want to use a low roll alarm, you're going to want to change that minimum roll size. So how this system also works in automatic is at 100%, this number, you're going to have 80 psi. At 0%, you're going to have 0 psi. But depending on the material that you're using, type of material, web width, you might want to adjust the actual pressure that you do have at full roll. You might not want 80 psi, even if your roll is 40 inches in diameter. So to adjust that, you could bring this percentage down. So instead of having 80 psi at 100%, or at full roll, you're going to have, let's just say, you're going to have 67% of 80 at full roll. This will allow you to bring your top end of that scale down and have a smaller low pressure window. We also just have a straight up on off, tension on off. This turns in both modes, it turns the brake pressure on and off for loading and unloading and setup. And that's about it with the mag power. Web guide. This is the controller. You have 3 modes: automatic, servo center, and manual. Manual allows you to manually adjust where the web guide is at. As you press in and out, you'll see the table move. Then you have servo center. Go to the table. You'll see when I press servo center, it'll automatically adjust to the center position and it'll stay there. Automatic mode now uses a small ultrasonic sensor that lines up with the web, and wherever you line the web up on this small little line right here, this will adjust as this web moves. If your roll is uneven, this will go back and forth, it'll adjust. So it will enter your module straight. So you put your web where you want it, and you can bring this sensor in and out. There's a small set screw underneath here. When you're done, you lock that set screw down, and then you have this small knob on the outside here that will give you your fine-tune adjustment. It will bring that sensor in and out. When you're adjusting the sensor to the web, you want to line this line up. There's a very small line on the top of here to the edge of your web. When it's lined up, the LED will be off. When it's out, it'll be red. When it's in, when it senses the web, it'll be green. It's moving all over the place right now because I'm moving the sensor. So we're going to put it back at the servo center mode. And right now in servo center mode, it's ignoring the sensor. The LEDs in and out, on and off, it doesn't matter. This is just going to be straight. And that's the web guide. The counter screen allows you to input your part length. This is how long your part that you want to count. You're going to want to input that in here. You have 0.1 to 100 inches. Input it, press enter. How many parts do you want to count before the machine will stop? That is your count preset. Input that, whatever you want. Press enter. I'm going to keep it at 0 right now because I don't want the machine to stop. After your machine has ran, this will accumulate. When you want to reset that to 0, that's your reset button. There is also a push button on the front control panel that has a yellow indicator that when you do reach your preset, that indicator will illuminate and the machine will stop. There's a batch function that when you are using a conveyor that supports batching, you would enable it here. Your batch preset is right here, and to put your number in, press enter. What the batch does is you would choose how many parts that you want to have shingled together on your conveyor, and then separated from the next batch. So say you wanted to have 10 parts that are going to come out together and be shingled on top of each other, and then you want to run 10 of those 10 part batches. You would put 10. So it's going to run 10 parts. The conveyor is going to index forward slightly to create a separation between the next 10 part batch. It's going to create 10 batches, and then the machine will shut off. That is only when batch is enabled. If batch is not enabled, this doesn't even matter. I'm going to put it to 0 at the moment. When this is not enabled, this preset is what will shut the machine off. This pulse input adjusts the time that your conveyor is going to index forward in between batches. You have 0.2 seconds to 1.5 seconds, and that will change the gap between the batches on your conveyor. You guys don't currently have a conveyor, so these features you are not going to be using right away, but you will most likely be using the normal counting functions, which is your part length, your count preset, your reset, this is your actual part count, this is your total parts, and then this screen also has the rate. The rate shows how fast the machine is going while it's running. One thing I would like to add about the conveyor that I forgot. You do, even with the batch disabled, you always have to have one batch. The next screen in adjustments would be island placement / gap separation. That is under the island placement tab. This adjustment adjusts the speed of the first station to the rest of the machine. This number represents a ratio. Right now as 1, the first module is going to be going the exact same speed as the rest of the machine. You can input a specific number, or you could just tab down. Lower, smaller numbers, or it's gonna make the servo motor first station go slower than the rest of the machine. So if we have 0.5 in here, we're gonna go half the speed as the rest of the machine. So at this point, we're gonna run the machine a little bit, and I'm gonna explain how to make an adjustment to create a gap or to do a island placement. You see we have a die in here that's basically cut to cut, no gap. And then we're running it down here, removing the liner, placing it onto a new liner, and there is currently a slight gap to no gap. And I'm going to adjust the screen on the HMI that is for island placement. So I currently made it 0.8, so it's going 0.8. The ratio is going to be 0.8 of the main speed, and you can see since the web is going slower and the other one's going faster, it's creating a space between. Now it's going half, and you can see the gap is growing. There are limits to how long your parts can be, because they are going to be on 2 liners at the same time. As you can hear, it's squeaking. Now I'm going to make it even longer. This is 0.2. And then I'm going to bring it back to 0.9. So at this point there should be a very small gap. If I were to make it 1, there should be little to no gap. Since it's going through the bars, there will be a slight gap. Naturally, the bars do create a slight gap. If I were to go above 1, that left side web, this side, would actually start to go faster, so the parts would kind of almost start going on top of each other. If these parts had a gap between them, on this other side, the gap would shrink. And that's about it for the ratioing servos.